Hello, Chemistry 10H students. This is Mrs. Altman, and this will be the first of two parts of videos about electron configurations. So if you're watching this and you've already finished all of Chapter 11, you'll want to watch both parts. I'm not going to be doing the shorthand version in this video. Next video, I will be. Okay, so an electron configuration tells you which orbitals actually have electrons in them such that we can predict the chemical properties of an atom. Okay, so this order can either be memorized, there's nothing wrong with doing it that way, or I actually see the periodic table this way when I look at it. I'm going to briefly explain it, but I will just say that some students never really see it. And if that's you, then that's perfectly okay. It doesn't mean that you're not going to be able to do it. So I view this whole section here as what is called the S block. So H on down, B on down. I view this section over here, so from boron all the way to 113, all the way over here up to and including helium. I view this as what is called the P block, although helium actually you could toss over there, but more on that later. Then I consider this section here, so from scandium to actinium, all the way over to number 112 to zinc. I consider that what is called the D block. And then down here, this is called the F block. We're not going to be doing too much with that. So the way I see it is I read it from left to right. So 1S, 2S, because it's in the S block and it's in the second row, 2P, 3S, 3P, 4S, and then you just kind of need to remember that for a D, you just do the row number minus 1. So instead of 40, it's 3D, 4P, 5S, 4D, 5P, 6S, and then it actually goes down here. You have to do row number minus 2 for F, but I'm not really going to be giving you ones with F, so you don't really need to worry about that. But just for the sake of completeness, 4F, 5D, 6P, 7S, 5F, 6D, 7P. So if you don't see it that way, it's okay if you don't. It'll mean that you will need to memorize it instead. Some students write it on the top of their paper before a test. That's completely fine. All right, let's work through some examples. So first thing I do is I go to the periodic table. I find how many electrons fluorine has, and it is 9. So I go in order, 1s, 2, 2s, 2, 2p, but now I only have 5 electrons left over, so I give it 5 electrons. So notice how the 2 plus 2 plus 5 adds up to 9. So you're always going to fill one up and move on to the next one, but your last one might have fewer than the standard number of electrons. So in case you need a refresher, S can have up to 2. P can have up to 6. D can have up to 10. And F can have up to 14. So I always fill it up to its maximum capacity before I move on to the next orbital. And then your last orbital might not be completely full. Now for sulfur, I go to my periodic table. I see that it has 16 electrons. So I start filling up. And then I have used 12 electrons. So I only have 4 more. So the next one is 3p4 instead of 3p6. I also know my answer is right because if I look at sulfur, it is the 4th element in on the p block. More on that next video, but it's just an easy way to remember your an easy way to check your work. So this, I don't even need to go to the periodic table, but it is zinc. But I don't need to because I know it has 30 electrons. But because I know it's zinc, I just see that it's in the D block and it's the 10th one in. So that tells me that's probably going to be, not probably, that's what it's going to end with. Now I'm in the 3D orbital. I have 10 electrons left over, and I can fit up to 10 in there, so just 3D10, and I don't move on to the next orbital. Now for beryllium, this one, I go to my periodic table. It has 4 electrons, just 1s2, 2s2. And I can't move on to 2p. Okay, I have another example here. If I haven't yet talked about charged atoms with you in class, you might not need this example. This is more for people who've already finished the packet but wanted a little bit more review on this topic. So for sodium, I go to my periodic table. I see that it has 11 electrons. I also see that it is the first one in the S group, S block, so I know it's going to end with S1. So from here, I've used 10 electrons, so I'm going to fill 3s only with 1 electron. For Na+, what that means is I remove an electron. And then because it's a charge of +1, I'm removing 1 electron. If it was +2, I'd remove 2. So 11 minus 1, I have 10 electrons. And then when it has a charge, I can no longer do the thing where I see it's in the S block, so therefore it has to end with S1. You could also think of it, instead of sodium, you're doing neon. That would work. That wouldn't be incorrect. And then from here, I'm just done. I don't need to add anything on. So Fe2+, I find iron on the periodic table has 26 electrons. I subtract 2, so it has 24 electrons. Or you could also think about it as though you are doing the electron configuration for chromium, which will end with D4. And then I only have 4 electrons left, so 3d4. And then the last one is S with a 2- charge. So this is sulfur, so it has 16. And then I'm adding electrons because it's a negative charge. So it's a total of 18 electrons. Or you could think about it as if you're just doing the electron configuration for argon. And then I've used all the electrons, so I don't need to move on to the next one. All right, I appreciate you taking your time to watch this. That is all for this video. Thank you so much for watching.